All right, my friends, we are on the last installment of the final exam review. This chapter should feel more familiar to you simply because it's something we just did, but let's get to it. The initial part is remembering that if you have a base and it has a fraction power, the top of that is going to be the actual power and the bottom is going to be the root index. I always think of roots on the bottom like in a plant. So if you have something like this, the base is 1, and you're going to have a root with an index of 8, and then the 7 can either go here, or sometimes you'll see it written with that 7 on the outside. So in this case, that use the 8 as the power, this is proper. This made 7 the base, and this made 8 the base. So my choice is B. So the base is always going to be the thing written to the power. So in this case, it's a 9. The number on the bottom will be my root, and then the power will be in with the 9, or you could have this all squared. Either one of those is going to be an acceptable way to write that. So in this problem, you're basically splitting this all up. You can kind of think of it a couple different ways, but you're dividing things out in groups of 3. You're doing the cube root of 64. The other thing you could do is write this as like each power over that root. So like x would be to the 3 over 3. Y has a 9 power 3 root. Z has a 12 power 3 root. You can use your chart or your calculator to figure out that the cube root of 64 is going to be a 4. Here, you just reduce the fraction. So 3 over 3 is 1. Here, 9 over 3 becomes a 3. And here, 12 over 3 becomes a 4th power. So I get z to the 4th power. Okay, and then looking at my answer choices, that appears to be sorry, I was looking at something else. That appears to match with C. Okay, in 85, I'm going to do the same thing. 5th root of 32 is going to be a 2. Then I'm going to have A power over root, B power over root, C power over root. So the 2 is just the 5th root of 32. A will be to the 2nd when I reduce 10 over 5. B will be to the 5 when I reduce 25 over 5. And C will be to the 1st when I reduce 5 over 5. Now, evaluate is different. Evaluate means you need to get a number. So you're using your calculator, and if you're going to type this into your calculator, you're going to use an arrow key and then the 3/5. Or you might have a button that looks like this. You have to kind of figure out what you need to use on your particular calculator to kick out the proper answer. And this one has a typo. It's actually 6.21. And that turns out to be the answer. So unfortunately, there's a mistake on the correct answer. So try that on your calculator. Make sure you can get that, like, so that you know in the future you can get that right. Same thing here. 82 is going to get raised to the, now this is my power over root, so it's 5 over 7. Or you're going to be using that x to the y power button, and then have that 5/7. But you have to let it know that you're raising it to the 5/7 instead of the 7/5, and you should get 23.28 out of your calculator. Now we're back to simplifying. Like, evaluate always means a number, get a value. So pay attention to those verbs. Simplifying, you're not going to get a number answer. So the rule here is you have to add the powers. The trick is you have to add them with a common denominator. So either you figure out how to do this on your calculator, or you have to revisit those skills. With 3 and 5, 15 is your common denominator. To turn 3 into 15, I have to multiply it by 5, so I adjust the top number by the same. Here I would have to multiply it by 3, so I adjust the top number by the same. So now I have 10 plus 12, so I get 22 over 15, and that's just the powers getting added together. So it's x to the 22 over 15 power. You do have to write it as a fraction, not as a decimal. And oops, that was multiple choice, so that's a C. Same thing here, except I'm bringing the power in. So I'd be multiplying 2/3 by 4/5. And in a lot of ways, that's easier because I don't need a common denominator. I just multiply the tops, I multiply the bottoms, and then I reduce if I can, but I can't in this case. So B is my answer. All right, here, this is saying take rule F and add it to rule G. Rule F is 2x plus 3. I'm supposed to add that to rule G, which is negative x minus 1. This is combining like terms. We actually went through this on an earlier part of the video. So 2x and a negative 1x gives me x. 3 and a minus 1 gives me 2. Here you have to be careful because we talked about this in the earlier video as well. If I take F and subtract G, it's like having a negative 1 that needs to distribute. So this becomes a positive x and a positive 1. So now when I combine terms, I end up with something completely different. And you just have to be conscious of the fact that when you are subtracting in between things, that you have to actually distribute that negative to everything after it. So this one is a little bit, okay, it has an extra set of parentheses that makes it weird. It's asking you to take F times G. So I'm going to take F times G. So we did this earlier in the video also because we learned how to manage all these polynomials in an earlier chapter. Now we're just adding in the function notation. This is going to be FOIL. So this is negative 2x squared. Outside is going to be negative 2x. Inside is negative 3x. And last is negative 3. These two are alike and go together. So I have negative 2x squared minus 5x minus 3. Here, notice this is different. G is tucked inside of F, and that's exactly what we're going to do, is we're going to take G and put it into F where there used to be an x. So I've got my 2 times something plus 3, but the something is the entire rule of G. So this is G getting plugged into F. So now I just do whatever math there is, and in this case it's distributing the 2, and then these two can combine. So negative 2x plus 1 is going to be my final outcome for that one. Here, I'm doing the opposite. F is tucked inside of G, so I'm going to take all of F and put it inside of G. So G has a negative, and then the x, and then a minus 1. And what you're putting in for the x is all of function F. So I put 2x plus 3 in there because it says take F, plug it into G. So here I'll distribute the negative and have negative 2x minus 3 and then minus that 1. These can go together to be a negative 4. So that's like an earlier skill we learned, but you have to first understand what they're telling you to do to plug stuff in. Okay, finding the inverse was a two-step process. You would swap the x and the y. So you would put them in each other's spot. So it would read x equals negative 2y minus 5. And then second, you would solve for y, meaning get y alone. So if you're trying to get this y alone, you just undo stuff. So to undo a subtraction, I'm going to add 5. Now I have x plus 5 equals negative 2 times y, but to undo multiplication, I need to divide. So in the end, my inverse, which we write like this, is going to, because that's like the fancy y, is going to be x plus 5 divided by negative 2. Same thing here. I'm going to put the x where the y was and the y where the x was, and then I'm going to move stuff around until I have this y alone. I'll start by adding 6. So x plus 6 equals 7y, and then divide by 7. So instead of writing y, we write our little fancy notation for inverse, and we have x plus 6 divided by 7. Back to solving. Okay, so we're solving a square root. So to get rid of a root, we'll ultimately need a power, but I need this part alone first. And I do that by taking away that 11 to the other side. So now I have the square root of 9x equals 3. To get rid of the square root, I'll need to square it, and whatever I do to one side, I have to do to the other. So these cancel, root and power cancel, so I have 9x equals 9. So when I divide, I just get that x equals 1, which is option A. Here, this entire thing is square rooted, so I'll have to get that part alone, and then I can square it. But to get it alone, I need to get rid of the 3, so I take it away. So now I have square root of x minus 25 equals 2. To get rid of a square root, I use a second power. It's gone, leaving me with just x minus 25 equals 4. And when I add over my 25, I find out that x is 29, which is choice C. And boom. All right, look at us. We're almost done. Okay, so clearly the problem here, is this. Whatever the tricky part is when you're solving, you have to get that alone. So I need to get this part alone, and I'm going to do that by adding 73 to each of these sides. So I end up moving that over and getting 243 on this side. And now to get rid of a fraction power, I use the reciprocal fraction power, meaning flip it over. So I had 5 over 3, I use 3 over 5. That way these all cancel, and I just have x minus 5. And then here you can either do this one using your card, or you could do this one using your calculator, but you need to end up with 27 as the right side. That's what 243 to the 3/5 power is. But we still need to add 5. So in the end, my answer is 32. So then my answer is B. All right, grand finale for the whole semester, yay. So in this case, the thing that's tricky is that power again, no surprise, but that power is a 5 over 6. I don't have anything else to get rid of, so I can just start by getting rid of that power. I use the reciprocal, 6 over 5, cancels all out. So 5x minus 21, and then I'm going to do 32 to the 6/5 either on my card or my calculator, and I'm going to get 64. And then it's algebra 1, add 21 to both sides, and then divide by 5. And when I do that, I get 17, which is A. Okay, so now the deal is, and this is like not a surprise, all the questions on the test are going to be matching up with questions on the final. So like here, both of these were solved in the same manner. There was probably going to be one like that on the test. 2 in a row said find the inverse, and the problems were really similar. There's probably one like that on the test. So if there's any area of this review that you don't understand, you want to make sure you go back and watch the video or look at the key or whatever you got to do, and maybe even put an example onto your cheat sheet so that you have good resources on the day of your final. Good luck, you guys. Be amazing.